Hi Algebra 1, this is Mrs. Martin here today with your last video of the semester with new lecture notes. And today's material is going to be on two-way tables and percent. So this is an introduction. And to guide our video today, I'm actually just going to walk you through homework 14, which will be your last new homework assignment for the school year. So let's get started. A couple of reminders before we start homework 14. You have unlimited attempts, so if you don't get the score you wanted the first time around, please take it again so you can earn back some more points that you might have missed. Remember that Alex only tests you on the questions, or it questions you on the problems that you missed the first time around, and that way you're not doing the whole assignment over again. And then it'll just add your points back to the beginning. So potentially everybody could get 100% all the way throughout this Alex material. Okay, so do your best and try multiple times if necessary. So let's go ahead and start off. We've already kind of worked with some data. We were able to find mean, median, and mode in the last video. You went so far as to learn about quartiles prior to that. So you've been doing a lot of work with statistics so far. So let's go ahead and look at this new type of problem. Just reading along with me, a movie club surveyed 300 high school students. The students were asked how often they go to the movies and whether they prefer comedies or dramas. Their responses are summarized in the following table. So here Alex has provided us a table, and the students responded about how frequently they went to go and see two different types of movies. Now, we can gather a lot of information from a table such as this, and for this Alex problem and the ones that follow, we're going to be focusing on percentages. So before we get started talking about percentages with the table, let's make ourselves a couple of notes about percentages in general. We're very familiar with fractions, and we know that fractions can be converted back and forth into decimals. Well, it turns out that decimals can also be converted back and forth with percents. Okay, and so when we're working with these, let's look at an example together. If I have a fraction like 3/5, 3/5 can be divided. So really what you're doing is dividing with fractions, right? You're doing 5 into 3. I know that 5 doesn't fit into 3. So I'm going to have to use some decimal work here. And then 6 5s fit into 30, and then I'm done. So some review of long division from back in the day when we learned this. So 3/5 is equal to 0.6. And yes, we've gotten accustomed to just plugging that into a calculator. But we also remember that it's coming from this idea of division, okay, this process of division here on the right. So I'm going to go ahead and erase that. And so it turns out that decimals can also be written as a percent. And the way we do that is we take 0.6 and we multiply it by 100, because remember, percentages are out of this concept of 100, and we get 60%. Okay? And this is how I calculate your grades when you get points on tests or homework. That's how those percentages are calculated. Another way to look at that is 3/5 can actually be written with the denominator of 100. So if I'm trying to make the denominator 100, I can multiply the bottom by 20 and the top by 20. Of course, I have to do 20 over 20 so that 20 over 20 equals 1, and I'm not changing the value of my fraction, I'm just changing the way it looks. We did this when we were doing fraction busters, right? And so when I do that, 3 times 20 is 60, and 5 times 20 is 100, and 60 out of 100 is 60%. Okay, so just a few things to be aware of as we try to work with this material. You know how to do percents already. Now it's just a matter of us pulling that information from tables and from scenarios with data so that we can answer different types of questions. When I see the word of, that's going to be referring to the denominator, the total. I'm talking about all of the students, okay? So for stats, when we're looking at setting up our fractions, our denominator is the total group, okay? And that could be all the students, that could be all the kids who like comedy, that could be all the kids who go 3 times or more a month, okay? The total of the group is going in the denominator, and then the frequency or the number of kids that actually satisfy a requirement is going to be the numerator. If you think about it in terms of a test, usually our total is 100 points, and the points you earn become our numerator. Let's make that a 90, okay? So with that being said, I've got over here of the students. So of the students is going to be my denominator. And when I'm talking about all of the students, it doesn't say in the table, but it did say up here on my scenario in my problem. So of 300 students, how many of them liked comedies? Now, unfortunately, our table doesn't really tell us how many total like comedies. It tells us comedies for the twice a month and comedies for the 3 times a month. What should I do to get the total for that row? I'm sure many of you already have an idea of what we should do to complete this. Our row total means we're just going to add these guys together. And when we add them together, we get 138. Okay, so I've got 138 students in this whole movie club survey. Out of all those 300, 138 of them say they went out and they preferred comedies over dramas. Okay? Now, Alex specifically wants a percent. So to find the percent, I could do long division here, but that would be a little time consuming. I'm going to go ahead and click on the Alex calculator so that Alex can do that computation for me. I've got 138, and I'm going to divide that by 300. Oops, sorry. And 138 divided by 300 is equal to 0.46. Now, I know a lot of you have the percent shortcut memorized, but if you don't, remember that to get a percent, I'm going to go ahead and multiply this decimal by 100. And when I do that, I get 46. So now I can go down here to A and type in 46%. 46% of the surveyed students prefer comedies. Let's go ahead and look at part B together. Part B says what percent of the students, so again, my total is 300. Now they want to know, of all those kids, how many of them go to the movies 3 times a month or more? That means we're looking at this column here, 3 times a month or more, which means now we're going to need a column total. Okay, which means we're adding up 36 and 60, and we're going to find that the total there is 96. 96 of all the kids surveyed went to the movies 3 times a month or more. And so I've got 96. And once again, I'm going to use my Alex calculator to help me determine 96 divided by 300, and then times 100. And I get 32%. And now I can go ahead and check. And we did a good job. So everything checks out. So practice with this. If you would like to try a new type of problem, you can always just try another, especially if you're trying to prepare for a quiz. So that's an option. And get used to finding row totals, finding column totals, and solving for percentages using the information given to you in a table. Let's go ahead and move on to question 2. . Question 2 is asking for something a little bit different. We're not looking for percents this time, but rather you're looking at data and trying to create tables for yourself. In this one, we're using a range. So notice here, we've got a range of numbers, 15 to 20, and we're trying to find out how many data points are in that range. So to get some context, read along with me. Here are the shopping times in minutes of 9 shoppers at a local grocery store. Complete the grouped frequency distribution for the data. In the distribution, the frequency of a class is the number of shopping times in that class. Okay, so, and when they say class, they're referring to the range of numbers. So 15 to 20 is a class, 21 to 26 is a class, 27 to 32 is a class. Another word we will use in class, in our classroom, sometimes is bins. Okay, we call them bins. And so now let's look and try and do this together. So 15 to 20, how many of those data points on the left are within the range 15 to 20? So let's go ahead and circle them. 20 is there, 30 is too large, 21 is too large, 19 is within that range, so that would be in that class. 22 is too large, 27 is too large, 29 too large, 15 fits, it's right there at the beginning, and 20. And so I can very clearly see that I've got 4 different data points that can be placed into this class of 15 to 20. Now I'm just going to rush through this some time, but within this same method, using the same strategy, I have 2 in the bin 21 to 26, and I have 3 in the bin 27 to 32. To make sure that I haven't made any mistakes, I'm going to go ahead and add these up. 4 plus 2 is 6, plus 3 is 9, and over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So I know I've accounted for everybody, and everyone's been put in its own separate bin here on the right table. So I haven't missed any numbers or accidentally doubled any numbers. That's really important to make sure you haven't done that. Now, with this data, you might be wondering, well, what's the point? Why are we finding frequencies of people shopping minutes? Well, when you're talking about different sets of data and perhaps maybe running certain businesses, when we're talking about shopping, we can see that most people manage their shopping between 15 to 20 minutes. And that might be important for different store managers to plan accordingly when they're allowing people to come into the store and shop, especially right now with all of the rules and regulations that have been set due to the coronavirus outbreak. Okay, so I'm going to go ahead and check our work here, make sure we did a good job. And it's correct, so we are ready to move on. And once again, you could click on try another if you want to get some extra practice in. I think stats starts to become a little more fun than some of the things you were doing before. So moving on to question 3. This time we're making a frequency table without bins or ranges or classes. Instead, we're making frequency on just solo numbers. This type of graph or table is usually created when you have qualitative data. We talked in the last video about qualitative data. For example, some of our data, I asked you what's your favorite color. That would have been a great topic to use to create frequency tables where I can count how many people liked blue, I can count how many people liked yellow, and so on and so forth. With this table, they actually have quantitative data where they're talking to 21 participants in a study on personality traits. They were shown 5 images, and each participant selected the one that was the most appealing to them. So it's possible that they were just trying to determine, for example, what people find attractive. Or maybe they were trying to determine, for example, what people, a picture of a person they thought looked trustworthy. These types of studies have been done many times. As a matter of fact, there are documentaries on Netflix that talk about all these studies, so you can check those out. But for now, let's go ahead and try and solve question 3 together. So first we'll start out with image 1. So we're starting here on this top row, and I'm counting how many people selected image 1. And it looks like I only had 4. So I'm going to go ahead and type in my frequency table that 4 people selected image 1. To continue on in this manner, I'm going to go ahead and count and let me choose a different color here, sorry. I'll count how many people preferred image 2. And it looks like only 3 for image 2. So people didn't like image 2 as much as they liked image 1. And notice that I circle my numbers. Some people like to cross out their numbers too. That's fine. Sometimes I find it hard to see the numbers underneath if I do that. But if you're crossing out numbers, that's okay too. By circling or crossing off or some other way marking your numbers as you move along, it helps you make sure that you're counting all the data points. So that's kind of important. Let's go ahead and move on. I'll pick a different color again. And we're going to count, we'll count the images, the people who selected image 3. 1, 2, 3, 4, 5. And I think I've taken care of all the 3s. For 4, I've got 1, 2, 3, 4, 5, 6. Wow, 4 looks like it was pretty popular. And finally, I've got 1, 2, 3 for image 5. And so again, since I've marked my numbers, I can clearly see in that box on the left that I've taken care of all the data points in my frequency table. And now I can come down here and check. Oh, there's an empty box. Oh, I didn't scroll down. There's more to this. Let's go ahead and erase these bubbles. Okay, so based off of this data, these images are associated with 4 personality traits, but not every image is associated with every trait. The table below shows the traits and the images associated with them. Okay, so we're looking at facial expressions in these images. In image 1, it looks like we had impulsive. To be impulsive is to act without thinking, okay? You just do stuff without thinking about it. Image 2 was analytic. You take time to analyze the situation. Image 3 was associated with 2 personality traits. It was associated with indecisive, and it was associated with analytic as well. So carefully analyzing, but having a hard time making a decision about it. Image 4 was analytic and optimistic. Analytic, again, analyzing the situation, looking at it carefully, and optimistic, being positive about that situation or that image. And finally, image 5 seems to have shown indecisive and impulsive. So doing things without thinking, but then being unsure about it. So that's how the 5 images were associated with personality traits. And continuing on with our ALEKS material, it asks how many participants selected an image that is associated with being indecisive. So let's look at this carefully. Being indecisive was associated with 3 and 5. So looking up at my frequency table, image 3 is here, image 5 is here. So I'm going to take those 2 frequencies and I'm going to add them together. So 8 people chose pictures that were associated with an indecisive nature. So let me scroll down, make sure I got everything. Okay, everything's taken care of. I'm going to check now. And I see that we did a good job. Continuing on with question 4, we're going to go ahead and create a two-way table. Now, in question 1, we used a two-way table. This time, we're going to make one for ourselves. And really, to make a two-way table, let me go ahead and erase this percent stuff here because I believe we're done with that. To make the two-way table, all we're doing is reading carefully. So let's start together. Each of 66 students in grade 7 or 8 was asked, "What is your favorite sport?" Here are the results. So we're going to go ahead and read this carefully. 12 students in the 7th grade and 6 students in the 8th grade chose football. With that knowledge, we'll go down to our two-way table. I had 12 students select football in 7th grade and 6 students select football in 8th grade. So it looks like the 7th graders like football a little bit more than the 8th graders. Continuing on, 9 students in 7th grade and 10 students in 8th grade chose swimming. So again, with my careful reading, I find for swimming, 9 7th graders chose swimming and 10 8th graders chose swimming. So 8th graders preferred swimming a little bit more than 7th graders. And finally, 16 students in 7th grade and 13 students in 8th grade chose baseball. So typing those in. Baseball, we had 16 7th graders. Baseball, we had 13 8th graders. And that takes care of that. So just by carefully surveying a group of people, we can take that information and we can break it down into a table called a two-way table. Two-way meaning we can read it going down, okay, see how many like football, how many like swimming, how many like baseball. And we can also read it going across, how many 7th graders were surveyed and how many 8th graders were surveyed. So let's go ahead and check our work. And we're good to go. Your last problem is similar, except that this time Alex is not giving you the labels. You have to choose the labels. So one thing to keep in mind is that our columns represent a response variable. And really that means what students responded with when you asked the question. Okay, so let's read this one. Each of 40 students in 1st or 2nd grade was asked, "Can you swim?" So remember, these labels here are called response variables, and they refer to the responses that students or participants gave. In this situation, if I'm asking, "Can you swim?" what kind of responses can be given? Well, really, there's only 2. Either I say I can swim, or I respond with I cannot swim. So now I've taken care of my response variables. And then to read my graph, my table across, obviously I'm not going to put can swim again. I'm going to go ahead and put my 1st grade participants and my 2nd grade participants. And just for your own knowledge, this side is called the explanatory variable. Before we move on, what do you think this group was trying to determine with this table? Maybe they were just trying to see if the older students could swim more often than younger students. That might be interesting to know. And it will also help people like me who run a summer camp sometimes. It would help us prepare for what we should expect if we take children on a field trip to a water park. Should I be prepared if I have small ones that they won't be able to swim? Or is it about even across the age groups? So let's go ahead and fill in this table now that we've set it up for ourselves. 11 students in 1st grade and 13 students in 2nd grade can swim. So over here under can swim, I have 11 students in the 1st grade and 13 students in 2nd grade. My next bullet point says 6 students in 1st grade and 10 students in 2nd grade cannot swim. So in the cannot swim column, I've got 6 in 1st grade and 10 in 2nd grade. And I'm going to check to make sure I had all the correct variables. And it looks like we did well. And that takes care of your homework for today. There's a whole lot more available for statistics. And I really think that statistics is a fun branch of mathematics that a lot of students like because it's a little more relatable, taking surveys, analyzing those surveys, understanding what it means when you get those analysis numbers. It can be a lot of fun. So in the future, when you're looking for classes after you finish Algebra 1, Geometry, and Algebra 2, set your sights on stats maybe. It does really have some interesting stuff, and it's a little easier to grasp since it's always got some really nice context going on. And that takes care of everything that I'm going to give you for Algebra 1. Okay, this is our last new lecture video. I will still be posting some updates for you throughout the end of the semester so that we can make sure that everybody's completing their work, that there's nothing missing, that if you have any low scores, you redo those so that you can have higher scores and I can update your grades. If you are doing homeworks that are late, know that I'm not taking off points if they're late. You will still get full credit. But just so that you know, it takes a really long time to go back to old lessons and see if you've done new work on those. So if you've done any missing assignments, especially in ALEKS, because ALEKS doesn't alert me, if you do old assignments in ALEKS or you redo any assignments or tests in ALEKS to get a higher score, if you want to see your grade change sooner, it would help if you sent me a message. So just send me a quick message on Schoology or Remind and just say, hi, Mrs. Martin, I did this assignment that was missing. Please update my grade. And that would be really helpful. It will just help me find your homework points a little easier, and then your grade will get updated faster. If not, you'll have to wait for me to find all the new work on old assignments. So I will still be available on your regular Zoom days. So if you need any help with any of the material, past or present, please feel free to sign on to Zoom and we can help you there. Thank you for all the work you've been doing. Thank you for your grit and your perseverance. If you have any questions or comments, you know where to leave them. Bye-bye.